24, question 46. The residence time distribution for non-ideal flow reactor is given in the figure. A first-order liquid phase reaction with rate constant given is carried out in the reactor. So let's say this is my non-ideal reactor. Inlet concentration is given. It's a liquid phase reaction. This is a first-order reaction, and normally this happens when there is short circuiting and dead volume. This kind of a square E curve we usually get. Anyway, so we know the equations which are very important. This is the first equation, that at exit for the non-ideal reactor, this would be this for a small batch of fluid, what would be the value? And we know that this is for first order reaction, this becomes is equal to e to the power minus kT for first order batch reaction, and of course multiplied by the ET value at that particular point ET. Okay, and the second one of course is very important, which is the integral between 0 to infinity of this particular curve, E curve, would be equal to 1. That is by definition. And we know the third one, this is for a small batch of batch reactor for first order reaction. Okay, so this one you already know, which is this one right here, and we have to evaluate this one. So as you can see, in this integral is the area under the curve. So this is E versus T curve. This is the area under the curve. So the area under the curve from here to here, 0 to 3 is equal to 0, and this also equal to 0. So this area should be equal to 1 according to this problem. So what will be the value? This would be of course going to be equal to, let's say this is H. So H multiplied by 5 minus 3 is equal to 2. That's equal to 1. Therefore H is equal to half. So this value is going to be, E value is going to be equal to 0.5 in this region. Okay. So so we come here so this could be broken down between 0 to 3, then 3 to 5, and 5 to infinity. For 0 to 3, E value is equal to 0, so this is equal to 0. Same way this is going to be equal to 0. And for this one, we know this is equal to 0.5 E value, 0 to 3 to 5 region, 0.5. And if we do the integration, which is shown in details here, how the integration is done, and we know the value of CA0 at the inlet, so the value of CA bar can be calculated, which is equal to 0.9044. So that is my answer.